Good day, everybody. How are you all? Today, we are going to talk about probability of independent events. In a prior video, we had talked about probability of dependent events. Now, we are going to talk about probability of independent events. Says 1 out of every 184 motor vehicles are stolen. Apply this statistic to 5 motor vehicles randomly selected. What is the probability that none of the 5 vehicles will be stolen? Okay, so let's do this. The probability vehicle is stolen is equal to 1 divided by 184, and that is equal to, I'm going to use my calculator, 1 divided by 184, and that is equal to 0.00543. So the complement event is vehicle is not stolen. Not stolen, sir. Not stolen. And probability of, no. So use probability law of probability law for company, or rule, I should say. So like rule for complement events. Remember, complement is opposite. Events which states that probability complement event, probability of complement event is equal to 1 minus probability of the event. So probability that the vehicle is not stolen is equal to 1 minus probability of vehicle is stolen. And that is equal to 1 minus 0.00543, which is equal to 457. So it is 0.99457. Okay, the vehicle is not stolen. Now it says part A. We select 5 vehicles, and what is the probability that none of the 5 vehicles will be stolen? So A, select 5 vehicles and find probability that none of the 5 vehicles is stolen. So we have to remember whether the first vehicle is stolen or not. Will not influence whether whether the remaining vehicles are stolen or not. Remaining vehicles are stolen or not. That means the state of each vehicle, whether stolen or not, is independent of the state of the other vehicles. No, of the state of the other vehicles. Vehicles. So my spelling is incorrect. So we will apply the multiplication rule. Rule for probability of independent events. Of independent events. Okay. That means the probability 5 vehicles are not stolen is equal to probability first vehicle is not stolen multiplied by probability of second vehicle not stolen multiplied by probability of third vehicle not stolen is not stolen multiplied by probability fourth vehicle is not stolen multiplied by probability of fifth vehicle not stolen. Vehicle is not stolen. So this is equal to Probability the vehicle is not stolen is 0.99457. Probability first vehicle is not stolen. Probability that the second vehicle is not stolen is also the same. Probability the third vehicle is not stolen is 0.99457. And probability that the fourth vehicle is not stolen is 0.99457. And the probability fifth vehicle is not stolen is also 0.99457. So this is equal to 0.99457 exponent 5. So in our calculator, we will do 0.99457. Then we will press this key, which is the exponent key. Exponent key 5 and then enter. And the answer is 0.99457, then exponent key 5 is equal to 0.9731. 0.97314. So that's your final answer. So just to summarize, we applied the probability rule for multiplication of, or multiplication rule for probability of independent events. So probability all 5 vehicles are not stolen is equal to probability of first vehicle is not stolen multiplied by probability of second vehicle not stolen multiplied by probability of third vehicle is not stolen multiplied by probability of fourth vehicle is not stolen multiplied by probability fifth vehicle is not stolen. So it's 0.99457 exponent to 5 because there are 5 vehicles. And our final answer is 0.97314. Okay. Let's look at part B now. So if I move it slightly up. What is the probability that all 5 vehicles will be stolen? Okay. And that probability, remember, is 0.0. Okay, so let's do part B. The probability the vehicle is stolen is 0.00543. So we go over here. So part B, we know probability vehicle is stolen is equal to 0.00543. So probability all 5 vehicles are stolen. Vehicles are stolen. Again, we will apply the probability rule for multiplication or multiplication rule for probability of independent events, which will be equal to probability first vehicle is stolen, vehicle is first vehicle is stolen times probability second vehicle is stolen times probability third vehicle is stolen multiplied by probability fourth vehicle is stolen multiplied by probability fifth vehicle is stolen. And remember, they get multiplied because these are independent events. So whether the first vehicle is stolen or not will not influence whether the second vehicle is stolen or not. They're all independent of each other. So if I create some space, this will be equal to 0.00543 times 0.00543 times 0.00543 times 0.00543 times 0.00543. So it will be equal to 0.00543 exponent 5. So in our calculator, we type in 0.00543, then press this key, which is the exponent key, to the power of 5, and then enter. And the answer is 0.00543 exponent key 5, and the answer is almost 0 actually, but we will write the whole thing down. So it is 4.7206, but probability cannot be greater than 1, so it cannot be 4.7, so there is an exponent part minus 12. What does it mean? Many people have asked me. It means the first digit 4 is after 11 zeros, or the first digit 4 is at the 12th place after the decimal. 0.00005 zeros, and 6, 7, 8, 9, 10, 11, and then the first digit at the 12th place after the decimal, and then so forth. So this is almost equal to 0. So probability not all, all 5 vehicles are stolen is very low. Okay. All 5 vehicles are stolen is very low. Okay. And probability all of the 5 vehicles are not stolen is very high, as you saw in part A, 0.97314. Okay. So I'll stop here. If you have any question or comment, you can write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I appreciate that. And if you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll be back next time with another interesting problem, interesting solution. And you can check out my channel. I have solutions to all kinds of math problems. And you can download them if you subscribe to my channel. Okay. I'll see you next time. Thanks for watching. Take care. Have a nice day.